Good evening to all. Next, proof number 49, symmetry of the roots. So this is actually one of the topics in quadratic equations. So first of all, what is meant by symmetry of the roots or symmetry of the function? So symmetry means, suppose if an expression or function remains unchanged on interchanging of alpha and beta. So here we are talking about symmetry of the roots. So here alpha comma beta are the roots of quadratic equation. Suppose if an expression or function in alpha and beta remains same or unchanged on interchanging alpha and beta is called symmetric function of alpha and beta. Symmetric function of alpha and beta. So anyhow, see, if we replace alpha by beta and beta by alpha, this expression remains unchanged. See, alpha power 5 plus beta power 5 is same as beta power 5 plus alpha power 5. So I am going to prove this relation alpha power 5 plus beta power 5 is equal to alpha cube plus beta cube into alpha square plus beta square minus alpha square beta square into alpha plus beta. Okay. Of course, there are many ways to prove this relation or this formula. See, here we can take RHS, then we can prove RHS equal to LHS. Okay, but it is very difficult to remember entire this expression. Okay, because this is too lengthy. Alpha cube plus beta cube into alpha square plus beta square minus alpha square beta square into alpha plus beta. So after several attempts, I finally got the answer. Here I am going to use binomial expansion, binomial theorem to prove this formula. So here I am going to take fifth power. Here we have alpha power 5 plus beta power 5. Alpha power 5 plus beta power 5. So here I am going to take fifth power of binomial alpha plus beta. Okay, fifth power of binomial alpha plus beta. If in case suppose we want to prove alpha power 4 plus beta power 4, then we can take fourth power of binomial alpha plus beta. So now fifth power of binomial alpha plus beta. So we can expand this fifth power of binomial using binomial expansion. So from binomial expansion, alpha plus beta whole power 5 is equal to, so it's like x plus 5 whole power n. Here n is equal to 5, x is equal to alpha, y is equal to beta. Let us expand this fifth power of binomial. So nc naught, what is the formula? Nc naught x power n y power 0 plus nc1 x power n minus 1 y power 1 plus nc2 x power n minus 2 y square plus nc3 x power n minus 3 y cube plus nc4 x power n minus 4 y power 4, and the last term nc5 x power n minus 5 y power 5. We cannot take nc6. Why we cannot take nc6? Because remember, in binomial expansion are always less than or equal to n. Here what is the value of n? 5. Here r is equal to 5. So what is the maximum possible case? Yeah, 5c5. We cannot take 5c6. Okay. Suppose if you take 5c6, here r value how much? 6 and n value 5. Remember, r cannot be more than n. Okay, na? Fine. So put n is equal to 5 and x is equal to alpha and y is equal to beta. Then it will be like alpha plus beta whole power 5 is equal to n 5c naught alpha power 5 beta power 0 plus 5c1 alpha power 4 beta power 1 plus 5c2 alpha cube beta square plus 5c3 alpha square beta cube plus 5c4 alpha power 1, beta power 4. At last, final step, phi c5, final term, phi c5, alpha power 0, beta power 5. So, okay. This is our expansion. Now, alpha plus beta whole power 5. Let us simplify further. Phi c naught value how much? 1. Phi c naught value 1. So, alpha power 5, beta power 0 value 1 plus phi c1. So, phi c1 value is equal to 5. So, use binomial coefficients formula NCR, n factorial by r factorial into n minus r factorial. Here phi c1 value, you know phi c1 value is 5. So, we will see why 5 and I will find this value. Okay, na? Phi c1 and all. First, let me write all values. Alpha power 4 beta plus phi c2 value 10. So, alpha cube beta square, and phi c3 value is also 10. Alpha square beta cube, phi c4 value 5. 5 alpha beta power 4. At last, phi c5 value 1. Alpha power 0, 1, beta power 5. Okay, na? This is the simplest, final expansion of alpha plus beta whole power 5. Now I am going to find phi c1, phi c2, phi c3 and phi c4. Okay, and of course phi c0 and phi c5. Let us find all the values of these binomial coefficients. Of course, I already written all values, but let us see how we got all these values. Binomial coefficient NCR is equal to, formula NCR is equal to n factorial by r factorial into n minus r factorial. So, using this formula, we can find values of binomial coefficients. So, phi c0, for example, suppose you want value of phi c0. Here n is equal to 5, r is equal to 0. Now, this formula becomes phi factorial by r factorial, 0 factorial into phi minus 0 factorial. So, phi factorial by 0 factorial means 1. Phi minus 0 factorial, 5 factorial. 5 factorial, 5 could get cancelled. What is the value of phi c0? 1. Now phi c1. So how to find phi c1? So use this formula, phi factorial n factorial by r factorial means 1 factorial, n minus r factorial, phi minus 1 factorial. Phi factorial by 1 factorial value 1, 5 minus 1 4. You will get 4 factorial. 5 factorial can be rewritten as 5 into 4 factorial by 4 factorial. 4 factorial get cancelled, you will get 5. And let me calculate one more binomial coefficient, phi c2. N factorial by r factorial means 2 factorial into n minus r factorial, 5 minus 2 factorial, 5 minus 2 factorial. So, ఈ ఫార్ములా యూజ్ చేసుకుని ఇవన్నీ ఫైండ్ అవుట్ చేస్తున్నాను. 5 factorial by 2 factorial into 5 minus 2, 3 factorial. 5 factorial can be rewritten as 5 into 4 into 3 factorial by 2 factorial value 2 into 3 factorial. 3 factorial get cancelled. 2 ones are 2 twos. And 5 into 2 how much? 10. Therefore, phi c2 value how much? 10. So, phi c0 1. Phi c2, so phi c1, sorry, 5. Phi c0, phi c1, 5. Phi c2, 10. Next, phi c3 you will get again 10. At last, one more, this is plus beta 5. Phi c4, value is also 5. Next, phi c5, 1. Phi c5 value 1. Okay. So, observe first term and last term. First term is alpha power 5. Last term is beta power 5. Let us group alpha power 5 and beta power 5. Alpha power 5 plus alpha power 5 plus beta power 5. This is actually my LHS. This is my LHS, alpha power 5 plus beta power 5. And transpose remaining all terms to left hand side. Here already we have alpha plus beta power 5. So now transpose this term, this term, this term, and this term. Positive 5 becomes negative 5. Minus 5 alpha power 4 beta. Positive 10 becomes negative 10. Minus 10 alpha cube beta square. Again minus alpha square beta cube. Minus 5 alpha beta power 4. Okay. Alpha power 5 plus beta power 5 is equal to alpha plus beta whole power 5 can be rewritten as alpha plus beta whole square into alpha plus beta whole cube. Okay na? So if bases are same, we can add powers. 2 plus 3, 5. You will get same expression. So we can write alpha plus beta power 5 as alpha plus beta whole square into alpha plus beta whole cube. Okay. Minus. Here let us consider this term and this term. See, here 5 alpha power 4 beta. Here minus 5 alpha beta whole power 4. Now observe common factor. What is the common factor here? Highest common factor is here. What is common among these two terms? Minus 5 alpha beta. 5 alpha beta. 5 alpha beta. And remaining. Here we have alpha cube plus. Here we have a beta cube. Okay na? So దీంట్లో 5 alpha beta, దీంట్లో 5 alpha beta తీసేస్తే ఇంకేముంటుంది, ఇంకా alpha cube ఉంటుంది ఇక్కడ beta cube. Next. Now observe these two terms. Common among highest common factor is minus 10 minus 10 minus 10 minus 10 alpha square. Here we can take alpha square. Here we can take alpha square, alpha square, alpha square, beta square, beta square, and remaining terms. Here we have alpha. Here remaining term is beta, alpha plus beta. Okay. Next, alpha power 5 plus beta power 5 is equal to, expand alpha plus beta whole square. You will get alpha square plus beta square plus 2 alpha beta. Here also expand alpha plus beta whole cube. Alpha plus beta whole cube. Alpha cube plus beta cube plus 3 alpha beta a cube plus b cube plus 3ab into a plus b. 3 alpha beta into alpha plus beta. Okay. Next, minus, let us write here, minus 5 alpha beta into alpha cube plus beta cube. Here minus 10 alpha square beta square into alpha plus beta, alpha plus beta. Okay. Let us proceed further. ఇంకా అలా మూవ్ అవడమే, మనకి అవుట్పుట్ RHS వచ్చే వరకు దీన్ని సింప్లిఫికేషన్ చేసుకుంటూ వెళ్ళాలి. Now let us distribute alpha square plus beta square. Alpha square plus beta square into alpha cube beta cube, alpha cube plus beta cube. Okay. These two are one group and these two are another group. Now distribute alpha square plus beta square into alpha square plus beta square into this alpha cube plus beta cube. Again alpha square plus beta square into this plus alpha square plus beta square into 3 alpha beta into alpha plus beta. Okay. Next distribute 2 alpha beta plus 2 alpha beta into alpha cube plus beta cube plus 2 alpha beta into this, 2 alpha beta into 3 alpha beta, 6 alpha square beta square into alpha plus beta, 6 alpha square beta square into alpha plus beta. Now write remaining, minus 5 alpha minus, let us write here, minus 5 alpha beta into alpha cube plus beta cube minus 10 alpha square beta square into alpha plus beta. Okay. Now observe like terms. See, these two are like terms and these two are like terms. Okay. Let us simplify these two and these two. Okay. Simplify like terms. Alpha power 5 plus beta power 5 is equal to alpha power 5 plus beta power 5 is equal to alpha square plus beta square into alpha cube plus beta cube. Okay. Plus 3 alpha beta into alpha square beta square into alpha plus beta. Minus 2 alpha beta alpha cube plus beta cube minus 5 alpha beta alpha cube plus beta cube positive and negative. We have to subtract. So you will get minus 3 alpha beta into alpha cube plus beta cube plus 6 alpha square beta square into alpha beta minus 10 alpha square beta square alpha plus beta. These two are like terms. 6 minus 10 minus 4. You will get minus 4 alpha square into beta square, alpha square into beta square into alpha plus beta, into alpha plus beta. Okay. So alpha power 5 plus beta power 5. So write this term as it is. Alpha square plus beta square into alpha cube plus beta cube. Do not change this term. Okay. So leave this term as it is because we need this expression. Next one. Now simplify this. Okay. First of all, distribute alpha and beta. Okay, to this expression. Plus 3 alpha beta into alpha square, alpha cube. Okay. Next. Alpha into beta square, alpha into beta square, you will get alpha beta square. Next, beta into alpha square beta, beta into beta square, beta cube. Okay, right, remaining as it is. Minus 3 alpha beta into alpha cube plus beta cube minus 4 alpha square beta square into alpha plus beta. Okay. Now distribute here 3 alpha beta. Distribute 3 alpha beta. Alpha square plus beta square into alpha cube plus beta cube. Okay, now this 3 alpha beta nu distribute chesedam. Plus 3 alpha beta into let us consider alpha cube plus beta cube as one term. Okay, one group, not term, one group. Then it becomes 3 alpha beta into alpha cube plus beta cube. Next, 3 alpha beta plus 3 alpha beta into, let us make these two as one group. 3 alpha beta into, you can write here, plus 3 alpha beta into alpha beta square plus alpha square beta. Okay. So distribute 3 alpha beta to alpha cube plus beta cube and alpha beta square plus alpha square beta. So ఈ రెండింటిని ఒక గ్రూప్ కింద తీసుకున్నాను, ఈ రెండింటిని ఇంకో గ్రూప్ కింద తీసుకొని 3 alpha beta డిస్ట్రిబ్యూట్ చేస్తాను. Minus 3 alpha beta into alpha cube plus beta cube minus 4 alpha square beta square into alpha plus beta. Right, remaining as it is. So next, alpha power 5 plus beta power 5 okay is equal to alpha square plus beta square into alpha cube plus beta cube, okay, plus 3 alpha beta into alpha cube plus beta cube minus 3 alpha beta into alpha cube plus beta cube. These two get cancelled. So here again observe what is common here among these two. Alpha beta common. Take out alpha beta. Okay, in these terms take out alpha beta plus 3 alpha beta into alpha beta common. You will get if alpha beta common, here you will have beta, and here remaining term alpha minus 4 alpha square beta square into alpha plus beta. So let us simplify this. Alpha beta into alpha beta, alpha square, alpha into alpha square, beta into beta square. So alpha power 5 plus beta power 5 is equal to alpha square plus beta square into alpha cube plus beta cube. So plus 3 alpha square beta square into beta plus alpha equal to alpha plus beta. Okay, na commutative property. Minus last term minus 4 alpha square into beta square into alpha plus beta. Now see, these two are like terms. Okay, na? Same variables with same exponents. So anyhow, plus 3 minus 4. 3 minus 4 how much? Minus 1. So at last you will get alpha power 5 plus beta power 5 is equal to alpha square plus beta square into alpha cube plus beta cube minus alpha square into beta square into alpha plus beta. Say 3 alpha square beta square into alpha plus beta is equal to minus 4 alpha square beta square into alpha plus beta is equal to how much? Minus alpha square beta square into alpha plus beta. Hence proved. Okay, na?